Before we start looking at this thing under magnification and using the tools that I just showed you, we can make some general observations about this rock, right? It's black or nearly black on over 2/3 of its surface. Now that's going to clue us in that it's a mafic rock, and it is technically plutonic. How do I know that? Because you can see the crystals, some well-developed crystals in here, and they're all bigger than 0.125 millimeters in size. So we have a plutonic mafic rock here, and that's the beginning of, that's going to take us in our direction as to where to classify it. And we can tell that it's mostly nearly black and white with some pink on it. Okay, I don't know if you can see it, with some I can't see it really well, with some pink or light red on it. Now, I'm not going to go through the whole thing about color, okay, but I will say this: things like tan, mauve, fuchsia, teal are not considered colors. If it's not on the Munsell color chart, it's not a color, all right? And in geology, we consider black and white colors, all right? Okay, since we know we have a mafic plutonic rock, we are going to use this classification chart right here, okay? We could use the mafic classification chart, which would be right here. This is our mafic chart, but we are not going to use this. This isn't really going to be applicable to much. Now, we do have something that's called norites up in Ontario in the Coldwell complex, but we pretty much, or not the Coldwell complex, excuse me, towards Sudbury, but that's an exception to the general trend. And a norite is, you could just call it a gabbro and stop there. But anyway, before I digress too much, let's try our first test. Now, we already decided that it's what its color is by looking at it, and that is our first test, color. And we can tell, we can say this is a very dark gray, veined or mottled white with either light red or pink. Pink is a legitimate color. You start with that. It's the most easily identifiable thing. You never use color to classify your rock strictly. Color can be used as an aid, but it in and of itself is never, ever, ever, I don't care what anyone says to you, diagnostic of rock type. Never. Okay, so let's get that out of the way. So that's our first test. See, it's done right there. We have our color. Well, in order to classify this rock, we need to be able to tell the mineralogy, what minerals are in this igneous rock. And we know it's crystalline. We know we're going to use the plutonic or phaneritic QPAF diagram, and I actually prefer the term phaneritic because it doesn't imply an interpretation. It just is what it is. And phaneritic versus aphanitic rocks, so coarse versus fine grain rocks, and you have pegmatites, are, that's basically, this tells you the borders between the rock. This is just for sand for comparison, but these are the size. You have millimeters here by scale here, and these are US sieve sizes. Obviously you can't break this rock apart into its individual minerals and run a sieve analysis on it. Obviously you can't, but it's there for reference. So to get our mineralogy, all right, let's start with the one we clearly have the most of, this dark gray or black. All right, is it one mineral? Maybe. Could it be more than one? Maybe. But before I look at it in hand lens to actually identify the mineral, I'm going to make sure by looking at it in hand lens that I don't have multiple minerals in here, multiple dark minerals. I'm going to see if it's homogeneous or if I do have two or more dark mafic minerals in here. Okay, so looking at this under my lighted, don't worry, I am going to show you through this tool what this looks like, just not right now. I'm just trying to count mineral types. I do have moving it around, seeing the way the light reflects off of them too can really help. I have two minerals here. I can see, definitely have two mafic minerals. One is dominant over the other. It looks like the vitreous one is dominant, so probably about 2/3 of it. So before I do any more detailed on this, I know now I have two mafic minerals in here, possibly more, but two major ones, and that's what I'm going to focus on. So I can do kind of like a streak test. I'm going to see if I can find a part of these mafic area where one mineral is really present over having both. So I can do a streak test on just one of the mafic minerals to help me identify it. That was a kitty sneeze. Okay, I've determined, see where my thumb is? That corner right there is pretty much the dark, dull mineral. So I'm going to take my streak plate and I am just going to scratch it on my streak plate and see what color that leaves. I gotta do it again. Sorry, I didn't do it hard enough. There it is. It's moving on me. Trying to do things for the camera doesn't always work out. Okay, I don't know if you can see it. You can see there are some gray streaks. Now, why do we do this? Well, we do this because even though minerals can vary in color, their streak is diagnostic. It's the mineral in powder form. It's what its color it's going to get if it's pulverized into powder. So that's why we do it. And since I'm doing mafic dark, I'm using my light streak plate, my white one. I said color is not diagnostic of a mineral, and that is true, but the streak is not color per se. Like I said, it's the mineral in powder form. All right? So the color of the mineral isn't diagnostic, but the streak can help. And honestly, there are minerals that can have more than one streak color, but they're close. Like, you're not going to have a mineral, although a mineral could be in its actual like crystalline form. It could come in yellow, green, blue. It could be clear. It could be black. But its streak is probably just going to be one color. All right, and it could have a colorless, no streak, essentially. Okay. But even if the streak does have multiple colors, which is rare, but it does happen, they're not going to be like, your streak isn't going to be like, one's not going to be, you're not going to have a green streak and then, or possibly a red streak. You're going to have like a green and a dark green, or you're going to have a yellow green and a green, or you're going to have a very light gray and a white, something like that. It's not going to be two totally unrelated colors, okay? Like the actual color of the mineral can be. Like calcite. Calcite can be any color, okay? It does, pick a color. Calcite could be it, and quartz can also be almost any color. But if memory serves, I believe quartz has a colorless streak. But there's other tests you can do to verify it's quartz, and you're going to see that here in a little bit. Okay, before we go any further, we're going to do another quick test here. We are going to see if we have sodalite, and there goes a cat, in this rock. So we're going to see if we have sodalite or, something that fluoresces. So we're hitting it. We have nothing that fluoresces in this rock. So we don't have sodalite, but we could still have voids. And sodalite is a void. Now, in our igneous rock, if you have primary quartz, you cannot have voids. You can't have them both. You can only have one or the other. And that's the part of the QAPF diagram. It determines if you're going to use the right side up triangle or the upside down triangle. So let's look at this thing under magnification a little bit. I got to get over here. Sorry, Blackie. Let's see. There we go. See how you can start to see stuff under magnification? Okay. We can see the mafic, the dark. See that luster, that reflection? Okay. And my streak tells me that I do not have any pyroxenes in this rock. What I likely have is biotite and hornblende. Hornblende has a gray streak like that. We are going to try to identify the Felsic or light-colored minerals now. I'm looking through my magnifying glass. Hopefully you can see something. You see this right here? You can see these lines. I see them like this. Those are striations. That tells me this is plagioclase. Now, can I confirm that? Yes, I can scratch it with a 6. Okay? Quartz won't scratch with a 6, and quartz does not have striations. And I can tell from about looking at this vein rock, we've already discerned that these dark mafics here are hornblende and biotite. We have, I think it's 22% hornblende, yes, and 44% biotite. Okay, so we know we have this plagioclase here, and this is a pretty good. This is a subeuhedral crystal here. I mean, it's actually pretty large. That'll come into how this rock formed later. So we know we have plagioclase. Can't tell you which one it is. It's definitely not microcline. Microcline is the only alkali feldspar that will exhibit striations, but it would exhibit them at 90-degree angles, and we don't have that here. We just have the parallel ones. So we look at the rock, and we can tell that maybe out of the white part, it's significant, but there is some white within here too. And if we scratch that with our number 6, if we can. If it's plagioclase, it will also scratch, and it does. Sorry, trying to keep it on it. If you scratch it in there, you got to remember when you're scratching a mineral to stay on it, and you can tell it scratches. So the white in between here also appears to be plagioclase, and it's probably 2% within the rock as a whole here, but in here it's a little more. We probably have maybe about total of maybe 6 to 7% the total rock. So we're going to put that down as our plagioclase, another 7%. Okay, so we have determined just by rock volume, and I actually did, confirm it the best I could, about 70% white plagioclase. Now we see here we have this pink here, this pink stuff. Let's see if I can get it there. Okay, this pink. All right, what happens if I scratch it? Well, I scratch it with the number 6. All right. You can see it pretty good. It leaves a nice, yes, I can. Okay. So that is not just weathered plagioclase. It could be. This is being underground. It looks like it's a weathering feature, but it's not. You look really, really carefully at that plagioclase, or at that pink stuff, really closely. There's no striations. You don't see any striations on it here. You don't see any striations on it here or anywhere else. It's alkali feldspar. Now, color is not diagnostic of rocks. Alkali feldspar is not always pink. Plagioclase is not always white. But in this case, we have a color difference between the two. And I would say that this rock here, I'm going to take it off this rock here, that the pink probably makes up no more than 3% of the rock total, of this thing total. So we're going to call that the alkali feldspar 3%. Okay, after looking at this rock some more and flipping it over some more, and scratching it some more, I realize our white plagioclase concentration is actually higher than that 7%. It's probably closer to 10 of this total rock. Possibly even 11 with the stuff disseminated within the mafic part. So I'm going to call that 11%. That's why you got to roll it over. See how this part is here? I didn't look at that, and that is mostly plagioclase in there. So we're looking not at 7, but about 11% plagioclase. That's why you kind of got to roll the rock over and look again and again and again to be sure. Okay, so now we're left with about 20% of the rock. And you can see here there's this translucent looking mineral here. All right, now it's possible that these are voids. But the three most common voids in the Midwest are lucite, nepheline, and sodalite, and they are soft. They have Mohs hardnesses of less than 6, typically 5 to 5.5. So if I scratch this with the 6 and it doesn't scratch, it's harder than that, and it's not a void. Doesn't scratch. When you do this, you apply pressure, but not so much that you break the tip. Now, we're going to go up 1. We're going to go to 7. If you look at it, you don't see any discernible features in it. It's what we call granular, massive. There's no crystal facies on this. I already know what it is, but 7 barely scratches it, but it does scratch it. So that means it's not a void and it's not a feldspar. It has to be quartz. This has to be quartz, okay? And quartz is a defining mineral, and its defining number of Mohs hardness is 7. And if we look at the rest of the rock here, look at the rest of it, we can see that part right there, that translucent part, makes up actually it's not within the mafics at all, but it is in these little veins a little bit. It is in the granular parts, in where plagioclase sticks out, and it's within the plagioclase pretty well. So there's a lot of quartz in here, surprisingly, but it's probably because of this vein. And although this vein is probably secondary and did not form initially with the rock, or if it did, it was late forming, we're still just classifying this as one rock. So we probably have maybe about 15% quartz in this. So I'm just going to say 15%. Okay, now that we have conducted our scratching tests and our streak tests, we can't do streaks on any of these. I tried. You can't get anything. But we got it on the hornblende on the mafics. Now we're still left with 5%. So I've looked at the rock thoroughly, okay? I have looked up and down it. I'm putting my tool away. Okay, I've looked up and down it to see if there's any other minerals in here or something I might have missed. And I do not think I did. All right, so which means something is at a higher concentration than I thought it originally was. Well, we already adjusted the Alkali Feldspar. I don't think there's more than that. But you see these pink, not the Alkali Feldspar. I already adjusted the Plagioclase, the white Plagioclase. My bad. And I don't think there's any more than 11%. I think the overall of the rock is probably pretty close to that. And I don't think there's any more Alkali Feldspar. I think 3% is pretty good on that. There's some little bit in the veins over here, but nothing significant. I think quartz at 15% is pretty good. So that leaves our mafics, our hornblende, and our biotite. And moving over and just going over and watching, what's sparkling in this is the biotite. It's the micas, okay? I don't think there's quite as much. Well, I think the 44% is probably accurate, but the remaining 5% is probably in the hornblende looking at this. So we're going to make hornblende 27%. Okay, now that we've got all of that, we can plot our rock type. Now, we have more than 50% of this as mafic minerals, dark minerals, so we probably should use the mafic classification chart for plutonic rocks, which is here. But the thing about using this is we don't have any pyroxene. This rock, using the mafic classification chart, is a gabbro, but it has significant amounts of feldspar and quartz. Around 15% each, is a hair under for the feldspar. So technically, this would be a gabbro with feldspar and quartz. So that would basically be the technical rock name for this rock as a whole. So we are going to still use this. Now, in order to do this, we need to normalize everything. We have our percents minus our mafics. Now, what we mean by that is, remember our mafics here, we had 27% hornblende, 44% biotite, okay? So we're excluding those. Now we need to normalize what's left. Our plage, our alkali, our AK, and our quartz, okay?
So that's going to become our 100%. All our percentages added up equal 29. So we just normalize. For quartz first, since we do not have voids, we're going to use quartz and we're going to use this part of the diagram. If we had voids, we'd be using this part of the diagram, okay? But we don't. So we're going to normalize our quartz because this does not function like a normal ternary diagram, okay? So we multiply our percent quartz by 100 divided by all of these added up, so 29, which in this case gives us this. So 15 times 3.448, you get that, and we have an average about 52% quartz. So our quartz here, this is 0, this is 100, this is 60. So 50 is right about here. So we're just going to draw a rough line, okay? Now we have to renormalize for our Plagioclase and Alkali Feldspar. We had 11% and 3%, which together equal 14. We do the same thing to normalize it. We have 79% Plagioclase, 21% Alkali Feldspar. Now, this is how it differs. So I take my 70, I can either use this number or this number. It doesn't matter because this is 100 and they have been set to 100. So I'm just going to do Plagioclase because it's 79%. It's closer to that. So from Alkali Feldspar, I swing 79%. This is 10, so we have to go here. So this is 65. So we're about right here with Alkali Feldspar and quartz. So we have I don't know if you can see it, but we have a granodiorite. So that is this rock on a QAPF diagram, okay? So that's how you would sit there and just determine your Alkali Feldspar, your QAPF, quartz, Alkali Feldspar, Plagioclase, void ratio on the chart here, QAPF, which is IUGS, to name your rock. Like I said, this has many, many mafics in it. Technically, if I just saw this in a box and didn't know anything like about where it came from, like I said, I kind of have an idea, even though I don't know exactly where Sarah picked it up from. But I wanted to show you the normalization process and to show you how to use this. And if we had this in outcrop, I guarantee you it came from this. So, but anyway, that is it. I hope you learned something. If you have any questions or comments, please leave them below.